Hi everyone, I am Sam. Today we are going to talk about game theory. Imagine for a moment that you're sitting at a small table in a quiet coffee shop. Across from you sits a close friend, someone you trust. You've both been detained, charged with a crime you may or may not have committed. The authorities separate the two of you, and now you each have a choice. Remain silent and trust your friend to do the same, or betray them by confessing and fingering them as the culprit. Neither of you can talk to the other. Neither of you knows what the other will do. Your choice may lead to freedom or a long stay behind bars. What do you do? This kind of situation sounds dramatic, and it is. But it's also a classic illustration of what's known as game theory. Game theory is the study of how people or groups or even nations or animals make decisions when the outcome depends not just on their own choices, but on what others do as well. It's about understanding how players interact, how they anticipate each other's actions, and how they might cooperate or compete to reach an outcome. The story about two suspects, each tempted to betray the other, is a classic scenario known as the prisoner's dilemma. Even if you've never heard of game theory before, odds are good you've run into this dilemma in popular culture, school discussions, or everyday conversations. But before we dive into the prisoner's dilemma or other famous examples, let's take a step back. Game theory didn't just appear out of thin air. It started as a formal field in the mid-20th century, though ideas about strategic thinking are as old as human conflict itself. Consider this. Military leaders, merchants, and politicians have been thinking strategically for thousands of years. Ancient generals weighed potential moves against their enemies' likely responses. Medieval traders haggled prices, guessing how their partners or competitors might behave. But it wasn't until the 1940s that a comprehensive mathematical framework to analyze these situations began to form. One of the founding moments of modern game theory can be traced to two key figures, John von Neumann and Oscar Morgenstern. Von Neumann was a Hungarian-American mathematician famous for his brilliance. Morgenstern was an economist at Princeton University. Together, they published a groundbreaking book in 1944 called Theory of Games and Economic Behavior. In it, they laid out the mathematical foundations for analyzing strategic interactions. They called these interactions games, not because they are always fun, but because they involve players, strategies, and payoffs, just like real games. When von Neumann and Morgenstern wrote their book, they were primarily thinking about economics. They wanted to understand how rational players, businesses, consumers, investors, would behave if they were all trying to get the best possible outcome. Imagine a marketplace where every company tries to maximize its profit and every consumer tries to get the best deal. How do you predict what will happen? Game theory, as they conceived it, would help illuminate the structure beneath these competitive interactions. It aimed to show not only what rational players should do, but also predict what they will do, given certain assumptions. One of the earliest significant developments in game theory after von Neumann and Morgenstern's work came from a young mathematician named John Nash. Nash was interested in what happens when each player in a game chooses a strategy knowing that every other player is also choosing their best strategy. He formulated what became known as the Nash equilibrium, a concept that is now a cornerstone of game theory. A Nash equilibrium is a set of strategies, one for each player, where no player can improve their situation by unilaterally changing their own decision. In other words, given that everyone else's choice is fixed, no single player would want to move away from their chosen strategy. To see why this matters, think of a simple game. You and a friend each choose heads or tails in secret. If you both choose the same side, you win $1 each. If you differ, you lose $1 each. In this silly little game, always choosing heads or always choosing tails can be part of a Nash equilibrium, because if you expect the other person to stick with heads, your best response might be to choose heads too. There's no incentive to deviate once you both settle into a pattern. Of course, this example is too simple to capture the complexities of real-life scenarios, but it illustrates the basic idea. A Nash equilibrium is like a stable agreement, even if it wasn't openly negotiated, and even if it doesn't yield the best possible joint outcome. When people talk about game theory, they often bring up the prisoner's dilemma. It's useful because it shows a very counterintuitive result. If both players are perfectly rational and care only about reducing their prison time, they might both choose to betray each other. even though they'd both be better off if they remained silent. To understand why, let's imagine the payoffs. If both prisoners remain silent, each might get a short sentence, say 1 year. If one betrays the other, the betrayer goes free, and the silent one gets, let's say, 3 years. If both betray each other, they each might get 2 years. Analyzed this way, no matter what you think your partner will do, betraying seems safer. But when both think that way, they end up with 2 years each, worse off than if they'd trusted each other. This scenario was not invented as a puzzle for criminals. It's a simplified model that shows how rational self-interest can lead to outcomes that make everyone worse off. It's an idea that resonates far beyond two suspects in a police station. It's been used to understand arms races. If both sides keep building more weapons, they both end up less secure. Environmental policy. If everyone exploits natural resources, everyone suffers in the long run. And even daily situations like overfishing, overhunting, or failing to maintain shared public facilities. As the field developed, game theory expanded beyond economics and military strategy. It began influencing political science, sociology, biology, and even computer science. Political scientists use game theory to understand how coalitions form in legislatures, how voting systems create incentives for certain behaviors, and how negotiations might unfold between countries. Biologists notice that animals, too, face strategic decisions. Think about how male birds might choose where to defend territory, or how predators decide whether to hunt alone or cooperatively. This gave rise to something called evolutionary game theory, which explores how behaviors spread and persist in populations over time. The logic is similar, but instead of conscious strategic thinking, creatures that behave in ways that yield better payoffs in terms of survival and reproduction tend to pass on their traits. Thus, strategies that are successful become more common. One key concept in evolutionary game theory is the evolutionarily stable strategy, ESS. An ESS is a strategy that, if most of the population adopts it, can't be invaded by a new mutant strategy. It's somewhat analogous to a Nash equilibrium, but framed in evolutionary terms. For instance, consider a species of fish that sometimes fight over territory. If a certain way of fighting or not fighting leads to better survival and more offspring, that strategy will spread. Over time, you might end up with a population that uses a stable strategy of aggression and avoidance, a balance that cannot be easily upset by a newcomer who tries a different approach. In economics, one famous application of game theory came from Thomas Schelling, who studied how conflict and cooperation emerge. During the Cold War, the United States and the Soviet Union stood in a nuclear standoff. Neither side wanted nuclear war. It would be disastrous for both, but each sought to gain leverage. Game theory helped strategists think about deterrence. If both sides build massive arsenals, is it stable, or does it provoke more tension? Schelling's work showed that sometimes having the capability to do something destructive, even if you never want to use it, can influence the other side's choices. This was a chilling real-world application of strategic thinking. Both superpowers were like players in a nuclear game, each deciding whether to escalate or negotiate, each trying to predict what the other might do. Not all applications of game theory are so grim. In the corporate world, companies try to outsmart their competitors, predict consumer reactions, and anticipate market changes. A business might ask, if we lower our prices, will the other company do the same? Will that spark a price war that hurts everyone? Or could we find a stable pattern where both companies keep prices at a profitable level? These are real decisions game theory tries to help us understand. Some researchers have also looked at coordination games. In these situations, players want to achieve a common goal, but they have to settle on a way to reach it. Imagine two drivers approaching a narrow bridge from opposite sides. They both want to avoid a crash, which means one must yield. If both try to cross, they crash. If both yield, no one moves. Ideally, one crosses and the other waits. Game theory can analyze such situations and suggest that the players might naturally coordinate on a certain pattern. Maybe the rule is that the driver who arrives first crosses first, or the one from the north side always yields. The point is that even without communication, expectations and conventions can form that guide behavior and avoid bad outcomes. As computing power grew and became cheap and abundant, game theory found new life in artificial intelligence and computer science. Algorithms now think strategically in online marketplaces, ad auctions, and recommendation systems. Online platforms must consider that users have their own goals. For example, Google's advertising system can be thought of as a huge game with thousands of advertisers bidding on keywords. Each advertiser is a player, and their choices interact to determine ad prices, placements, and who gets the user's attention. In recent decades, the influence of game theory has been so widespread that it's sometimes hard to pinpoint where it isn't. Its language of players, strategies, and payoffs has found its way into everyday talk. But we should be cautious. Game theory, especially in its classic form, assumes that players are rational and seek to maximize their own benefit. In reality, humans are complicated. We have emotions, we make mistakes, we change our minds. We might value fairness, loyalty, or kindness, and not just personal gain. As psychology and behavioral economics have shown, real people often deviate from the pure rationality that classic game theory assumes. Still, these deviations don't mean game theory is useless. It just means it's a starting point, a model to help clarify a messy world, rather than a perfect crystal ball. Imagine a simpler world for a moment. Two farmers share a field. If they both work too aggressively, they deplete the soil. If they both hold back a bit, the field recovers and both prosper. Game theory suggests there might be a stable way to share that resource if each farmer expects the other to act wisely. Yet, in reality, mistrust, misunderstanding, or miscommunication might break down cooperation. Humans might try to establish rules, sign contracts, or rely on social norms to avoid the worst outcomes. Now guess what? Those attempts to set rules and norms themselves can be analyzed through the lens of game theory. How do these agreements form, and what incentives keep people from breaking them? This brings us back to the narrative style of understanding game theory. Instead of imagining abstract formulas and payoff matrices, picture real-life dilemmas. Two siblings sharing toys, two companies deciding on prices, two countries negotiating a trade deal. The key is that each party's decision depends on what the other might do. When both parties understand that fact, they start anticipating each other's moves and so on, like a hall of mirrors, reflecting decisions back and forth. Historically, as economists and mathematicians developed the formal language of game theory, they created many categories of games. Some games are zero-sum. One player's gain is exactly another's loss, like in a sporting match or a poker game. Other games are positive-sum. Cooperation can make everyone better off, as in a business partnership or climate treaty. Some games are played only once, while others are repeated over and over. Repetition allows for learning. And punishment strategies. If you betray me once, I might retaliate in future rounds, which might discourage betrayal in the first place. This is crucial to understanding how trust and cooperation can emerge. One of the most astonishing insights is that even in a world of selfish, rational players, cooperation can arise naturally if the same game is played many times. Political scientist Robert Axelrod famously ran tournaments in which different computer programs played the prisoner's dilemma repeatedly. The winning strategy was surprisingly simple and became known as tit for tat. This strategy cooperated on the first move and then simply copied the other player's last move afterward. If the opponent cooperated, tit for tat cooperated next time. If the opponent betrayed, tit for tat would betray next time. This simple rule encouraged cooperation. Being nice from the start established a tone of trust, and punishing betrayal discouraged further bad behavior. Even though game theory often highlights conflict, it also helps explain how and why cooperation might be the most successful long-term approach. Of course, the world doesn't hand us neat games with known payoffs and a limited number of strategies. Real situations can be messy, with incomplete information and uncertainty about the other side's motives or options. Game theorists deal with these complications by expanding their models, analyzing games of incomplete information, where players don't know everything about each other, or dynamic games, where actions unfold over time. Despite the added complexity, the same basic idea applies. Think about the other player's perspectives, anticipate their responses, and find your best move given their possible choices. One historical note worth remembering: before game theory became an established field, strategies were often discussed in less formal ways. Philosophers, generals, and business leaders had their own intuitions about how to manage conflicts and alliances. Sun Tzu's The Art of War, written thousands of years ago, is all about understanding your opponent's mindset and adapting your strategy accordingly, an early, informal form of game theoretic thinking. Machiavelli's The Prince, penned during the Renaissance, discussed how rulers might maintain power in a world of cunning rivals. Again, a strategic analysis that mirrors game theory's essence. The difference is that modern game theory tries to put these intuitions on a solid, mathematical footing, allowing for more precise analysis and predictions. As you write your own narrative, remember that game theory is not just about complicated math or high-level diplomacy. It's about everyday life. Whenever you try to guess how another person will react to your decision, whether that's calling your friend, deciding when to show up at a party so you don't arrive too early, or figuring out how to share chores with your roommate, you are engaging in a tiny piece of game theory. You are considering the interplay of choices and outcomes. In its most basic form, game theory is about empathy and strategic foresight, putting yourself in someone else's shoes and asking what they'll do if you do something. For teaching purposes, think about simpler, more relatable examples. Suppose you and a friend want to meet for coffee. Neither of you wants to send too many texts. If you both wait for the other to choose the time, you'll never meet. If you both pick a random time without telling the other, you might miss each other. A cooperative outcome would be one where one of you suggests a time and the other agrees. Although trivial, it's a coordination problem. Just a simpler version of the complexities that game theory aims to solve. Or consider fashion trends. Suppose a new style of shoe is popular only if enough people wear it. If you think everyone else will buy those shoes, you might buy them too, because then you fit in. But if you think no one else will buy them, you might avoid them, not wanting to look out of place. Your choice depends on your expectations of others' choices. That's a coordination game in disguise. In summary, the heart of game theory is this. It helps us understand strategic interactions. It gives us tools to dissect complex situations where outcomes depend on multiple decision makers, each with their own goals. Historically, it began as a specialized branch of mathematics and economics, shaped by people like von Neumann, Morgenstern, and Nash. Over time, it has reached across boundaries to influence political science, biology, computer science, and beyond. Although it often assumes rational, self-interested players, its lessons remain valuable even when we acknowledge human quirks and complexities. So the next time you face a tough decision that depends on what others might do, pause and think about the situation as if it were a game. What are your strategies? What are the other players' strategies? Is there a stable outcome where no one has an incentive to change their mind? Could everyone be better off if you found a way to cooperate? These are questions that game theory encourages us to ask. And while it may not always give you a straightforward answer, it provides a lens to see the hidden structure beneath everyday dilemmas. And remember that the prisoner's dilemma, as dramatic as it sounds, is just one illustration. The world is full of games both large and small, some about trust, some about negotiation, some about mere coordination. Understanding even a little bit of game theory can give you the vocabulary and insight to recognize these patterns, anticipate problems, and sometimes avoid them. After all, if you ever find yourself across the table from a friend, each of you with the power to betray or cooperate, wouldn't it help to know you're in the middle of one of the most famous games of all time, and that knowing it might just guide you toward a wiser choice? That's all for today, and I'll see you in the next episode.